Hey guys, this is section 14.3 from Algebra 2, and this is really the last thing we're going to cover this year. Normally we get through a bit more, and I think we could get a lot of really neat stuff done, but just with the way that it's going to fall, this is kind of the end of the road for us. And for some of you, this will be a very simple assignment. Others, this is going to feel confusing and you're going to feel lost. And so my best encouragement to you is come in during office hours, ask for help. If you have to get help to walk through all 10 problems, that's okay, as long as by the end of that 10 problems, you have a sense of how it's to be done. There are going to be 2 problems on the test for the chapter, or the quiz for the chapter. They're going to come from this content. And so there are right here about a dozen identities, 10 or so identities. And when we say it's an identity, what we mean by that is that it is something that we can claim to just be true. Now, can we prove them? Absolutely. Have they been proven? 100%. But we are just going to go ahead and make a couple of, we're going to accept these as true values that we could just move on with. For instance, the tangent, it's always been defined as the y over the x. But we know that the sine is the y and the cosine is the x. So whenever we see the term tangent in an equation or an expression, we might be able to simplify it by changing it to sine and cosine. Similarly, cotangent can be changed into cosine over sine. When it comes down to simplifying these expressions, these problems, the general rule that we're going to kind of go with is that sine and cosine are what we would call the favorite children, sorry. They're the favorites, okay? So when there's not really a clear path forward, we want to turn everybody into sines and cosines. And so while it is true that sine is 1 over cosecant, it's also true that cosecant is 1 over sine. So you can see all of these different identities. If we're trying to simplify, there's going to be 2 types of simplification, okay? Up here, we have simplification where we're trying to reduce the number of parts in the problem. This would be about, if I see this secant over here, maybe I'm going to do something with it related to what's over here, the tangent sine. Maybe I don't like tangent times sine. Maybe I can clean that up a little bit. And in doing that, maybe I can get to a better place, okay? So this is going to be an example where we're going to go through this problem, and it's going to be about, tangent, I don't know what to do with it, times sine. Maybe if I change tangent to sine over cosine, maybe I can do something there. And secant, I don't know what to do with secant, but maybe writing 1 over cosine, okay, would work better. So we're going to kind of play with these a little bit. The other identities are called Pythagorean identities. We'll talk about those here in a second. What I'm going to do here is I'm actually going to walk through 3 of these problems with you, trying to give you a sense of how they're to be done. On this first problem, you need to understand, on all 10 of them, I'm giving you the answer. The answer is the cosine of theta, or the cosine of x. Our job is to show how the left side is equivalent. We do it by substituting identities. Okay, so for instance, I'm not sure what I'm going to do with secant here, so the easy option is to just turn it into a cosine. I see that secant right here is the same as 1 over cosine. So I can write 1 over cosine. And I could write the theta. I'm just going to drop it all together. I'm getting lazy here. Minus. Instead of writing tangent, I'm going to write what tangent's equal to. This one here, where you say tangent is 1 over cotangent, I wouldn't ever write it unless I had a cotangent in the problem somewhere. And since I don't, I'm going to come over and select this. Instead of tangent, I'm going to put sine over cosine. And I still have times sine. That sine over here is really over 1 if it makes you feel better. Nothing's going to cancel. This is just about combining it together. So what I end up with is 1 over cosine. Whoops. I'm going to have to move this page down a little bit. 1 over cosine minus sine times sine is sine squared, and it's over cosine. Now, when 2 things have the same denominator, it's possible for us to combine them into one. If you think about it as 4/3 minus 2/3, well, we can just take 4 minus 2 and put it over 3, which means this can be written as 1 minus sine squared over cosine. All right, so we're looking at this, and I'm thinking, okay, this still doesn't look like cosine, but here's where the payoff comes, okay? We'll talk about those other identities we haven't really talked about yet. This 1 minus sine squared. All of the Pythagorean identities have a squared value, either 2 squared values and a 1, or a 1 and a squared value, things along those lines. If we look at just this first version of the Pythagorean identity, it says that sine squared plus cosine squared equals 1. If we took this and said sine squared plus cosine squared equals 1, and we moved the sine squared over to the other side, sine squared would cancel sine squared, right? I'd get cosine squared equals 1 minus sine squared, which means that when I see this 1 minus sine squared here, I can replace it with cosine squared. Now that cosine squared is over a cosine. Well, when you have something squared over itself, I mean, this cosine squared is really cosine times cosine. So this cosine would cancel one of the cosines up here, leaving me with the cosine of theta. Did I get to the answer that was provided? Yes. It's about the process that we take to get there. Understanding the process is what you're really going to be tested on. I'm going to show you, like on the test, I won't show you the answer. I'll just ask you to give me the answer. But you want to make sure you understand the process, and I don't want you to do these without a sense of what's to be done or when are you done, okay? You're going to have to become comfortable with these identities. Now, these identities, they're there for you on the day of the test. Feel free to use these. In fact, this whole worksheet that you're doing on 14.3, this entire worksheet and your work, it's open to you the day you take your test. I'll try to talk about that when I send the test out, but this trig identity worksheet with all the identities there, it's yours to use. Okay, let's take a look at some more examples. Hopefully we can get something figured out here. Let's take a look at number 3. Number 3 is a bit of a doozy, so we'll start there, and then maybe we'll come down, and I don't know, we'll try I don't know, number 5 maybe. Down here they get a little bit easier. Some of these are really easy, so I'm not too worried about it. They'll get easier as you go. I kind of did that on purpose. I picked a couple of hard ones to start with, but let's look at number 3. So I see a secant, a cosine, a tangent, a cotangent. I really feel like I should probably just turn these into sines and cosines. So first off, there are no squared values. I don't have tangent squared or anything like that. So an easy option is to just turn everybody into sines and cosines. If we look back up here, secant is 1 over cosine, tangent is sine over cosine, cotangent is cosine over sine. You might have to pause it, go back and forth. But here the secant, I'm going to write it as 1 over cosine. Now that's still over cosine. Okay. Minus tangent is going to be sine over cosine over, and this is cosine over sine. This actually happens quite a bit in these types of problems. We have a fraction over fraction. And so we're going to create this idea of fractional refraction, and we are going to flip in times. So right here, I'm going to times by 1 over cosine, because that's the flipped version of this. And here I'm going to times by sine over cosine, because that's the reciprocal of this. In the first fraction, I'm going to have 1 over cosine squared minus sine squared over cosine squared. Well, there's a couple of different ways to approach this. I mean, I've got a couple of choices. It's really up to you. This is one of the challenges in these types of problems, is that There isn't just one right way. I'm going to choose a path here. If you feel like there might be a different path, take that other path and see if it gets you to the same place. But 1 over cosine squared, well, 1 over cosine is secant. 1 over cosine squared would be secant squared minus sine over cosine is tangent. So sine squared over cosine squared would be tangent squared. Now that looks like a Pythagorean problem. In fact, if we come back up here, grab a different color highlighter here, secant squared minus tangent squared is by definition 1. And if we look right here, secant squared minus tangent squared, that equals 1, which is the answer we had at the beginning. All right, so we can see how this is kind of working. You're going to have questions still. Please don't just say, oh, I don't get it. Come ask your questions. I'll try to help you out the best I can. I've done this for a long time. It takes doing it to understand it. There are some things, guys, that you can do and they just make sense from the very beginning. Maybe you think that riding your bike was always just such an easy thing that you never had to do any work. I've got kids. We've taught them how to ride bikes over the last several years. It takes work. And then when it clicks and you really get it. Let's look at one more example. Let's take a look at let's take a look at number 10. Number 10 is as good as any. All right. When we look at 10 here, this has cosecant squared, cosine squared. Now, I want you to know right now, traditionally, that's not Pythagorean. But when I look at the answer, do you see that has a squared value minus 1? That feels like a Pythagorean problem. So I'm kind of left in this weird spot where is the left side Pythagorean or is the right side Pythagorean? Like, what do I do? Remember, we're only moving the left side. The right side just tells us the answer. Well, like I've said before, when all else fails, we try to turn things into sines and cosines. And cosecant squared would be the same as 1 over sine squared. And that's times cosine squared, which would technically be over 1. When I multiply those, I would get cosine squared over sine squared, which equals, now cosine over sine, come back up to our definitions, cosine over sine, okay, cosine over sine is cotangent. So if we come back down here, this would equal the cotangent but squared of theta. Now we're sitting here thinking, okay, I got it down to a single trig function. How do I get it from cotangent squared to be cosecant squared minus 1? The answer is we've already done it. We just have to go back to our trig identities here for our Pythagoreans. If we look at the Pythagorean identity that uses cotangent and cosecant, if we were to get cotangent alone, we would have to do it by adding cotangent squared, which would produce that cosecant squared equals 1 plus cotangent squared. But then how do I get cotangent alone? I would minus 1. So cotangent squared is by definition cosecant squared minus 1, which, come back down here, that was what our goal was. Cotangent squared is cosecant squared minus 1. The goal, guys, is for you to see the path. Because if I take away the answer and I say, hey, what's an equivalent version of this? Yeah, I need you to be able to get somewhere. I will say this up front, though. This answer right here, cotangent squared of theta, is simpler and therefore more elegant. If I was doing a test and just building a test question, this would be the answer because it's so clean and precise. Not a lot of extra stuff going on. All right, like I said at the beginning, you have questions. This doesn't make perfect sense. But we're trying to stretch here. We're trying to extend ourselves a little bit. And so, yeah, you're going to have to work a little bit. Come in during the live chats, get the help that you need so you can be prepared for your test next week. But yeah, good things are happening. Good luck.